everyone, my name is Edward. I'm going to be talking about building our Iceberg Destination Connector. So a little bit about me, I'm an engineer at Airbyte. I work on the Platform Move Destination Connectors team. That's all you really need to know. So why are we here? The short answer is someone told me to make this presentation. A lot of people were very excited when we were working on this connector, both within the company and within the community in general. That's not what I'm actually talking about. I just want to sort of fanboy over the Iceberg spec. Talk about some cool facts that I think you should know, and that's not just a bad pun. There are legitimately like a bunch of Iceberg features that I think will make your life easier if you need to build your own version of this connector. So I want to go over two things that will make your life easier and two things that we ran into as sort of challenges and lessons to learn. A little bit of background. Iceberg is our first real data lake destination. Previously we had Databricks, which really we treat more as a standard warehouse, and we have an S3 destination, but it's really up to the user to take these files and work with them in your Spark or Snowflake or whatever instance. S3 Data Lake is our first time building a destination connector that's really supposed to just work out of the box, and we put a ton of research into that. A lot of internal discussion on, what are our users going to need and how is this supposed to actually work. So the good news is, if you've built a destination integration before, Iceberg is going to largely look very similar. Certainly for Airbyte, converting our type system to the Iceberg type system, converting Airbyte records into Iceberg records, Parquet in this case. This is all very, very familiar. Shout out to our beta users, a lot of good feedback in this region of sort of how they wanted those mappings to look. And obviously there's the usual destination specific stuff, handling naming conventions and so on. Again, if you've worked with destination connectors before, this is going to look very familiar. Iceberg's not doing that much differently in this space. But let's talk about some stuff that is very special about Iceberg. And I think the big thing to take away from this is, if you're going to work with Iceberg, it pays off to understand how it works under the hood. So I just want to go over that right now. So you can see here, I've stolen this from the Iceberg docs. You start off with your Iceberg catalog. This is your Nessie, or your AWS Glue. It has a pointer to a file on S3, the metadata file. And that metadata file just lists all of the snapshots in your table. Iceberg stores a history of all of your table's data, so you can track changes over time. And each snapshot knows what data files belong to that snapshot. This is where your big data lives. You can see that these data files actually get shared between snapshots. So we're not literally copying all of your data on every update, but every time you insert records, every time you delete records, Iceberg makes a new snapshot. So that's really cool. What this gives us as a feature of Iceberg is you have transactions. I'm not going to go into how that works, so you can read the docs yourself. Transactions are great. You should use them. They're unfortunately not actually a great fit for what Airbyte is doing. Right? By definition, we are trying to make continuous forward progress. We don't want to actually roll back on some kind of error, but they are cool. Snapshots also give us the branching and tagging features of Iceberg, which if you used Git before, this will feel very, very familiar to you again. Essentially, you can assign names to each snapshot. Iceberg suggests that you could use this for historical audit logs. We're actually using this for checkpointing, and the idea here is sometimes syncs will get interrupted. And if that happens, you don't want to start over from the beginning. You want to be able to resume from where you got interrupted from. And normally, that's really annoying. Your connector needs to periodically commit data somewhere, persist it durably, and then on restart, find that data again, figure out where it sort of got interrupted, make sure that it gets all that data. There's a ton of code that goes into this for most connectors. But with Iceberg, it's actually super straightforward because we just do all our work on this Airbyte staging branch. Most query engines target the snapshot that is currently pointed at by main. This is a special reserved branch name in Iceberg. But we can, put batches onto the Airbyte staging branch. Every time we resume, we just keep putting more snapshots onto staging. We don't need to do any complex recovery logic. And then at the end of the sync, we can fast forward main to catch up with staging. Super straightforward, very, very clean. But if you thought that was cool, let's talk about this other thing called truncate refresh. And this is an Airbyte specific feature. It's essentially a full refresh override sync that you can run on demand. You can think of this as truncate table in your destination, pull everything out of your source, put it into the destination again. Except a little bit more complicated than that, because that's actually really bad user experience. If we actually did that, you'd have to wait for your data to slowly refill for hours or maybe even days. That's just really not a great time. So we have this product directive which is called no data downtime, which is essentially don't actually do that. And instead, we have to do this complicated song and dance with temporary tables and eventually like Indiana Jones style swap it out at the end of a sync. And this leads to a lot of complexities, right? This is the actual flowchart that we use internally to talk about truncate refresh. There's a huge number of edge cases that we have to handle in terms of like, okay, your truncate refresh got interrupted. How do you figure out that your previous sync, you know, how far did that get? What if you cancel a refresh and try to start a normal sync afterward? What is the correct behavior there? But for Iceberg, because we have branches, it's also super straightforward because we just do that delete on our staging branch, right? Again, your query engine is targeting the main branch. We can do whatever we want over here. You won't notice until we fast forward main to staging. So even though on our branch, your table is empty, from your perspective, all that data still exists. And then at the end of a sync, we atomically fast forward main to staging. You get that one-shot atomic operation. Your table is never empty. Fantastic. That being said, there are definitely some challenges with Iceberg, right? It's not all smooth sailing. So the big one is it is a data lake, right? We don't have access to a compute engine. We are just putting files onto S3, or you know, your storage layer of choice. Certainly a connector isn't doing heavy compute, right? Airbyte connectors run with one CPU out of the box, I think. We're not going back and rewriting a terabyte of data on one CPU. And we also decided pretty early on, we're not gonna ask our users to provide a Spark cluster. That's just like, that's a lot of complexity. We don't want to deal with that. You don't want to deal with that. So you might be asking at this point, like, how do you support all these features which would normally require compute, right? How do you do dedupe without being able to go back and match existing records? How do you do schema changes if you need to rewrite old data files to match the new schema? The short answer is you don't, right? Iceberg supports merge on read. You don't have to do copy on write. So you can imagine in every sync, we are just putting more and more data files into your destination. Behind the scenes, maybe your compute engine is compacting these for faster queries, but like, that's up to you. We don't want to enforce anything on that level. But let's go into a little bit of how this works in detail, right? I mentioned earlier that Iceberg supports deletes. These are equality-based deletes. You can say, delete this primary key value, and that gives you a basic upsert operation of just like, delete that primary key, insert the new version. But that's not quite true, actually. If you do that, you'd really like to be able to do a cursor-based comparison, right? Conditionally upsert if this incoming record is newer than the one that exists. Because otherwise, if you have out-of-order data processing, you're going to have older data overwriting newer data. That's not great. And you know, this is one area where if you've got better thoughts, I'd love to hear them. Because our solution here is essentially just assuming that sources behave nicely, right? Either a given primary key shows up once per sync, or if it shows up multiple times, those multiple times are ordered by cursor value. And for the most part, that does hold true. If you're doing like select star out of a database as your source, you're going to get every record once. If you're tailing a CDC log, you'll get those records in order. And we don't even have to take too much of a performance hit on the destination side within our connector, as long as we partition primary keys off to the same thread consistently. We don't, you know, we can still run quickly. So that's great. Schema evolution is kind of in a similar boat, right? We could just say, hey, we'll blow up on incompatible schema change, right? If you change something in a way that would invalidate your older data files, just fail. Tell the user, sorry, you need to fix this. That's not great user experience, obviously, because you know Airbyte says you have to fix this thing and then you go somewhere else to fix it. So we landed on a sort of compromise, which is if we're doing a truncate refresh, just force that schema change to happen. We know we're already rewriting all the data files. We don't need to worry about the ones that actually already exist because we're going to abandon them anyway. And that is a better user experience. The second challenge is sort of like Iceberg suffering from success, if anything. There's a bunch of different catalogs, right? The ecosystem is wide and varied. So if you're building a connector, you have to like build automation for all of these tests. In order to do that, you have to stand up an instance of all these catalogs. And you better do that because every catalog has varying levels of support for all of Iceberg's features, right? If you have like many Nessie-based catalogs have slightly different branching semantics from vanilla Iceberg, or like Snowflake, you won't actually respect your delete files when you're querying an Iceberg table as an external catalog, and concurrency sometimes behaves weirdly. So the upshot of all that is, at Airbyte, we certified it against our connector, against specific catalogs, where we know it works, it's going to work well out of the box. But yeah, all that to say, we've got a new certified connector. Go check it out. Also, go read the Iceberg spec. Again, it is super, super valuable to understand how Iceberg works under the hood, and the spec is actually very readable. So yeah, that's all I got. Thank you for your time. Have a nice day.